This is a recording of Algebra 2. We're on page 160. Currently looking at example 1. We're looking at how to operate with matrices. And we're learning how to add. And in order to add or subtract a matrix, they must have the same dimension. And you just add the corresponding elements together. So let's look at example 1. Okay, who wants to do the first element when we add them together? What do we add? Row 1, column 1. Thinking good. I might think. Row 1. You just do it in whatever order. I would go each row first and then across. So what's going to be the first element in our matrix? What? That's the first one. I mean when we add. What do we do first? Where do you want to start? What are our two matrices so far? Oh yeah, I forgot you gotta eat your lunch. A and B. Somebody, come on. What do you need? Thank you. And no, you're right. You add row 1, column 1 with the other row 1, column 1, which is 4 plus negative 3 is what? 1. We found the first element. Find the row 1, column 2, Ella. Is? Right, negative 6 plus 7 is 1. Jessica, find row 2, column 1's element.
Row 2, column 1.
Yes.
2.
And then the other one for B.
The other one, yeah, the other one's 3.
Nope.
Wait.
Row 2, column 1 in
Row 2.
B.
Okay. Oh. I see. Okay. Row 2, column 1, 5.
Right. So what's 2 plus 5?
7.
7. So we just found 7. Okay, and I will do the last one, the bottom right-hand corner of the square. 3 plus negative 9. 3 plus negative 9 is negative 6.
Not a problem.
Yeah. So we look at the bottom of our example, and we see we got 1, 1, and 7, negative 6. Okay. What about letter B? It's the same thing. Can we do this? What should you look at first? Right. What's the first matrix dimension? Right. And what's B's dimension? Right. So can we add these? No. Do you see that, Jessica? On part B? Hello? Jessica?
Hold on a sec, I can't hear you. This phone's being weird.
I hear people in the background.
Yeah, I was on speaker so I could put the phone down and read. But anyway, did you ask me a question?
Yeah, on part B. Can we add those?
Can we add?
Because remember what's difficult about adding matrices? What? They must have.
I don't remember the rule.
Well, what is the dimensions of the first matrix?
3 by 1, or yeah, 3 by 1.
No.
1 by 3.
No. Part B. It starts off with 3, negative 7, 4. That's 8.
3, yeah, negative 7, 4.
That's one row. What's the other row?
Oh, and then 12, 5, and 0.
So
Oh, I see.
What are the?
So it's 2 by 3.
There we go. And what's the second? What's B?
Second one is 2 by 2.
So can we add these?
No.
No, because we have, the dimensions are completely different. So there's nothing to add the last column to, right? There's no corresponding elements to row 1, column 3, and row 2, column 3. Okay. Phew. Let's look at the top of the next page, and we're going to learn subtraction. Subtraction is just like adding. You just subtract all the corresponding elements. So let's try an example 2. I'm not even going to bother with the key concept block, because again, it's the same. You just subtract elements. So Ella, how about you start with the first element? Okay. And we're subtracting. So what's the first element in our new matrix? Right. 9 minus 3 is 6. That's right. Josiah, how about you do row 1, column 2? 2 over 6 is. Okay. Jessica, you row 2, column 1.
Row 2, column 1. Okay. So that's -4 minus. Okay. So it's -4 minus 8.
Yep.
And that's -12.
That's right. And all the last one, 7 minus -2. Well, 7 minus a -2 is 7 plus 2. So that's 9. So remember, whatever row column you're in, you must put your answer in the same row column. Very important. Okay? So you can look at the example, and we have 6, -4, -12, and 9. So we did it. Oh no, word problem. Let's look at example 3.
I have a question.
Go ahead.
When you have a matrices, for example, the answer to the problem that you just did, when you are reading the answer, is there a specific order that you need to read the answer in?
Well, not necessarily, but conventionally, because you can do it anyway, but conventionally you read all the rows first. So you read row 1, then you read row 2.
Like 6, -4, -12, 9.
Right.
All
Because
right.
they're going row by column, just like all the dimensions.
All right, thank you.
Uh-oh. Use matrices to model real-world problems. Data. Okay. This is example 3. It's in the middle of the page, and it's right below example 2. Animals. Okay, that's good. I like animals. The table below, I gotta make this a little bigger. The table below shows the number of endangered and threatened species in the United States. Or what? Oh, in the United States and in the world. Okay? So how many more, keyword math words, hope you're listening. How many more endangered and threatened species are there in the world than the United States? How many more than? What kind of a problem is a how many more than? Yeah, it's a subtraction problem. Absolutely. So check out this. We got type of animal, and we've also got the United States. Endangered, threatened, endangered. So first we have to build this, right? What's your favorite animal in this? Everybody tell me what their favorite animal out of these are. For fun. Mammals, birds, reptiles, amphibians, or fish. What's your favorite class of animal, Josiah? Fish. What about you, Ella? What? Birds. What about you, Miss Chris?
I like reptiles.
What about you, Miss Jessica? What's your favorite animal class?
Mammals, probably.
Me too, because I'm a mammal. So is the car. That's right. Okay. So do you see the outline of this table? Across the top, we got the United States, and then we have endangered versus threatened, and the bottom, and then we have the world. So if it were me, and I bet the book's going to do the same thing, you basically set up the matrix like the table, and they did. Good. So you just have to remember when you're going down your rows, so the first row represents mammals, the second birds, the third reptiles, and so on. And then across So how would you set this up? If you didn't have this book in front of you, how would you set this up? Because we want to know how many more the world has over the United States. So what are we subtracting from what?
U.S. total.
How many more does the world have over the
Yes,
U.S.?
we do world minus the U.S.
Right. We have to do world minus U.S. That's right. So in the table, they have it United States world, right? So you have to swap them. Does that make sense, Jessica?
Yep.
The keyword was how many more than with the world first. So if you just look below the little paragraph where it says the data, you'll see how they set it up at the very bottom of the page. They put all the world data on the left and the U.S. data on the right, and they did all their subtractions. Like, for instance, what's 309 minus 61? So on. Does that make sense? Do you want me to go through all of this, or are you good? Questions? Because you guys never ask questions, so it usually indicates to me that you're doing fine. Silence is grinding. I don't like it. Well, it's the same procedure. Row 1, column 1, minus US row 1, column 1. World 24 minus US row 8. So for instance, okay, here's my question. If you wanted to know how many more amphibians are there in the world over the US? This will test how much you understand about this problem. Use the book's answer, if that's fine. How many more amphibians are there in the world over the US?
You mean endangered and threatened?
Okay, good point. Let's do endangered. How many more endangered amphibians are there in the world over the US?
That makes a little more sense.
How do we figure out where we're at? Yep. If you are asking questions, I want to ask you questions. What do you think it is? Okay. What do you think, Jessica?
It's 8.
Okay. Josiah? Okay. How many more threatened, let's go for birds, are there? World versus US more than birds. Threatened birds.
6.
Okay. That's great. And how about threatened mammals? Bunty.
16.
Okay. Does that make sense? Not too bad, was it? And
No.
if you turn the page, it's at the top of the next page. So now for scoring sake, we're at the top of page 162. And they have the full and completed matrix. So again, you just set it up like usual and subtract row 1 from column 1 from row 1, column 1. Write your answer. Again, make sure it's in the same place where you found it. Okay. Scalar. Find scalar in the middle of the page, below the example. Scalar multiplication. Big. Right?
Found it.
Found it, Jessica?
Yep.
Okay. You can multiply, that's what a scalar means, matrix by a constant number. Well, I guess they say equation, same thing. So it's known as a scalar. This operation is called scalar multiplication. Okay. So look at the key concept box. So the product of a scalar k, because math likes letters for everything, right, is of an n by n matrix is another n by n matrix in which each element equals k times the corresponding element of the matrix. So they do it here in symbols. They have a k, and then they open their matrix A, B, C, D, E, F. So your answer is just k times A for your first element, k times B for your second, and k times C, and so on until you finish that. Let's do it. Okay, example 4. Multiply a matrix by a scalar. Alrighty, we're multiplying A by 3A. Oh, no, wait, find 3 times A. Got it. So what do we mean when they say find 3 times A? What do we do? Yeah, we multiply every single element in there by 3. So what's 2 times 3? What's 8 times 3? Negative 3 times 3. 5 times 3.
9.
You're
15.
just being quick. Negative 9 times 3. 2 times 3. Right.
6.
That's right. So we got them all. So in the book they write 3 times A equals, and then they put a 3, and then they open up your original matrix. And then they do it again. They put another equal sign and open up a new matrix where they put every single element in parentheses. 3 times 2, 3 times 8, and so on. Finally, they get to the bottom where they have what you just said. 6, 24, negative 9, 15, negative 27, and 6. Scalar multiplication is my favorite. Any questions about that one? Okay. So again, you just multiply every single element in by whatever they give you. 3, 5, negative 10, 7,000, doesn't matter. Oh boy. Many properties of real numbers also hold true for matrices. Alright, let's figure out what they're talking about. Check out the concept summary. Oh boy. Remember these properties I made you learn at the beginning of the year?
They look familiar.
For matrices A, B, C, and with the same dimensions, E here, same dimensions, and any scalar lower c, that's confusing. Why don't they leave it k? The following properties are true. Alright, the commutative property of addition. So again, remember the commutative property? 2 plus 3 is the same darn thing as 3 plus 2. Well, matrix A plus matrix B is also the same thing as matrix B plus matrix A. So you can just swap them around and add the same way, right? The associative property of addition. This is where you can swap all those parentheses around. So it's open parent A plus B close plus C. You can change that to where the A is outside of parentheses, A plus open B plus C close. And of course, everybody's favorite, the distributive property. This scalar times parentheses A plus B close, just like in math, is the same thing as C times A plus C times B. Does that make sense? So you can pretty much like use, apply the associative, commutative, and distributive properties of matrices. Now, remember, it's not so easy when you're not using numbers. With matrices, you're working with blocks of numbers. So I just want to remind all of you to be very careful when you're adding and subtracting stuff, because you might miss something. Let's go to the next page at the top of 263. We're already on example 5. Now we're going to do combination matrix operations. So whatever they give you, they're going to ask you, they give you an A and a B, and they want you to find 5A minus 2B. What would you do first? We have a 5A and a minus 2B.
So does that mean that we multiply like all the A matrix by 5 and then the
Right.
B matrix by 2?
That's what I would do. I would scale first. She's right. Multiply A by 5 and then multiply B by 2 and then subtract. It's a lot of work, isn't it? And so you're right, Jessica. So let's see. The book did that, except they kind of all did it at once. They did 5b, or yeah, excuse me, 5a minus 2b, and then they wrote it out. 5, and then open the matrix and put all that stuff in. And then they have a minus 2, and they open the matrix and put all that stuff in. And then they break it down for you, where they multiply everything and leave the minus sign between. So 5 times 7, 5 times 3, and so on. So, as you go, make sure you don't forget that your minus sign is in there. Because when you get to the point where you actually have to combine the two matrices, you don't want to forget your sign. So what they finally come down to as a subtraction problem, it is the third matrix down. Okay? Do you see it, Jessica, where it starts with 35?
The third, yeah, just a second.
No problem.
Oh, yep, I found it.
Yeah, 35, 15, negative 20, and negative 5, minus 18, 12, 6, and 20. So then you just proceed as usual. 35 minus 18, 15 minus 12 is 3, negative 20 minus 6, and so on. And then at the very bottom, finally get to one single matrix. 5a minus 2b is the same as 17, 3, negative 26, and negative 25. Okay, how do you feel? Is that too horrible? Alright.
It sounds like it's going to be more time consuming than anything.
Yeah. Yeah, that's kind of true. Let's see here. Let's see. Perform the thing indicated. Okay. Let's just, I want to give you one of the, oh good. Okay. How about 4 to 9? 4 to 9.
Oops.
4 to 9, and, oh, gotta give you a word problem. Sorry. And 4 to 9, 11, and 12.
11 and 12.
Yeah.
What page is that?
Page, the one at the, below, it's right below the example on 163. Page 163, 4 to 9, and 11 and 12. Lots of
163.
people have for word problems. 163.
53?
63. 163.
Oh, okay, I got it. Awesome.
No problem, it's probably for Stormy's benefit too. Page 163.
Alright.
So again, when you're adding and subtracting, first check your dimensions. Do you have to check your dimensions when scaling?
Okay, so
Do you?
enter P equals.
Do you have to check your dimensions when scaling? No! All you do is multiply every single element. This is just for you. It's good. Because you're going to learn how to multiply matrices together tomorrow, and you're not going to like it. Alright, again, 163, 4 through 9, 11, and 12. Alright, I am stopping the recording. I hope you feel better soon.